NASA joined the ExoMars program, the launch was delayed several times. Ultimately, the decision was made to use the U.S. Atlas rocket. And more importantly, the space agencies would send a test lander and orbiter to Mars first, followed by the rover. The launch for the first part of the mission was set for 2016. Then, the ExoMars rover was scheduled for launch in 2018. It would be launched with a second rover designed by NASA. Could Earth be the only planet to support life? For the longest time, scientists thought there was life on Mars. Until the 60s, color changes on the planet's surface were interpreted as a possible presence of vegetation. The Mariner flybys confirmed this wasn't true, but questions about Mars' surface remained.
Earth is the only planet in the whole solar system to have water in liquid form, but we have good reasons to believe that there used to be liquid water on Mars, only it disappeared after 100 million years.
We know that 3 or 4 billion years ago, there were lakes and rivers on Mars, just as there were on Earth. During that period of time, life started on Earth, so why not on Mars as well?
If it did exist, it might not be life as we think of it on Earth, but there could be single-cell microorganisms in a very primitive state.
There could be unicellular beings made of very simple structures such as bacteria, protobacteria or viruses. If these kinds of things were to exist out there, we'd be able to identify them and maybe even analyze them on the spot.
The search for traces of life outside the Earth is at the very core of exobiology.
Exobiology is trying to figure out if life is possible outside our planet. Answering that question would prompt new ones about the way life arose on Earth. Is life mundane in the universe? Is it rare? Is it unique?
Mars is a rough environment, probably too rough for humans. Its diameter is roughly half that of planet Earth, and the average temperature is minus 62 degrees Celsius.
Mars is a very challenging planet. There's differences in temperature of 100 degrees between day and night. At night it gets very, very cold, minus 120 centigrade.
Atmospheric pressure is very low on Mars. It's pretty much the same as what can be found on Earth at an altitude of 35 kilometers. The air around you is cold, but it isn't very dense, so you don't really get the feeling of being cold.
Severe dust storms the size of continents are frequent on the planet.
The Martian atmosphere is completely different than ours. It's composed of 96% carbon dioxide.
The Martian atmosphere is very thin, so even though the wind can get up to relatively high speeds and blow dust around, the atmosphere is so thin that it doesn't have a lot of push power.
But Mars is similar to Earth in some ways. A Martian day is only 40 minutes longer, and the gravity on the red planet is 1/3 of that on Earth, something humans can adapt to.
On Mars, you would weigh 0.38 times your actual weight. That's almost a third. I weigh close to 75 kilos. That's 28 kilos on Mars.
The surface of Mars is subject to lethal cosmic rays. The soil, rich in iron oxides, is what earned Mars the nickname Red Planet.
When you're down on the surface of Mars, it really does have a reddish hue, and the atmosphere, instead of looking on a nice clear blue sky day like we have here on Earth, there's actually a slightly pinkish cast to the atmosphere because of that red Martian dust suspended in the atmosphere. It's red. Think of it as the rusty planet.
It's interesting because from where we stand, the sun takes on an orange color when it sets, because it goes through the atmosphere. From Mars, on the other hand, sunsets are blue. We received wonderful pictures from Curiosity where the blue sun sets over an orange sky.
Scientists take the evolution of Mars very seriously because Earth could quite possibly follow the same path.
We don't want, in the future, our planet to look rusty as Mars is looking now.
Like Earth, Mars was a water planet that could have supported life billions of years ago, before it turned into the frigid desert we know today. We owe that amazing bit of information to American rover Curiosity, which landed on Mars in 2012.
It would not be fair to call Mars barren when it comes to life underground. There's water under the surface. It's even liquid in some areas. So why wouldn't there be some sort of life form under there? You never know.
Curiosity has provided proof that liquid water flows on the surface of the planet. What really happened to Mars? Answering that question could provide clues to the mystery of the origins of life on Earth.
We don't know how life started on our planet because the oldest traces of life we know of are 3.5 billion years in age.
Life on Earth could have been set in motion by Martian meteorites. It's a very serious theory.
It's a theory among many others that could potentially benefit from the results of the ExoMars mission. But 4 years before the launch, the mission nearly came to a halt. In early 2012, European Space Agency President Jean-Jacques Dordain received a distressing phone call.
C'est l'administrateur de la NASA.
NASA Administrator Charles Bolden called me in person to tell me that NASA wouldn't be able to contribute to ExoMars as agreed. This really came as a shock.
NASA left the ExoMars project because it was unable to secure funding for both missions.
Actually, I was in USA, and the people from NASA came to me saying that they were extremely sorry, but they understood that they were going to leave the project.
When you put a lot of energy and the momentum is ongoing, and then you find what looks like to be a stop, a showstopper, obviously you're not happy.
The Russians took this as an opportunity to participate in the ExoMars mission.
Mars was a personal challenge for the Russians after going through so many setbacks and technical malfunctions.
In March of 2013, the historic agreement was finalized, cementing the involvement of Roscosmos as an ExoMars partner. The ExoMars program moved forward with some changes, and the cost grew to 1.2 billion euros, with the addition of 2 Roscosmos Proton launches.
So people that believes that we are doing ExoMars since 2005, it's not completely correct. I mean, the real mission, the one you see now, has been really generated only a couple of years ago.
The 2020 mission will include an ESA rover and a Russian descent module. The first launch will hold the trace gas orbiter and the lander. A successful mission could provide more clues to life on the red planet. 7 months after the launch and 3 days before reaching Martian atmosphere, the lander, called Schiaparelli, will be ejected from the orbiter at 21,000 kilometers per hour. A parachute and thrusters will help it slow down enough to land on the planet.
The TGO has 2 tasks. The first one is to bring Schiaparelli to Mars. The second objective is to make experiment possible around Mars.
The Trace Gas Orbiter is a fairly large spacecraft. The weight is about 3,700 kilograms, including the fuel on board.
The Trace Gas Orbiter is a space probe designed to stay in orbit around the planet Mars.
The difference between Curiosity and ExoMars orbiter is that the rover takes precise measures over a limited area, while ExoMars offers an overview.
The device will be fueled with bipropellant for orbit insertion and major maneuvers. It will also be powered by its gigantic solar wings and 2 lithium-ion batteries. The key goal of the TGO is to analyze atmospheric gases present in small concentrations, less than 1% of the atmosphere. Among these gases is methane.
May you remember that in Mars Express, one of the things that we got was a hint about methane. We are going to measure methane with an unprecedented precision, much, much better than Mars Express.
According to scientists, the presence of methane could be a significant clue to the past presence of life on Mars.
Methane always has to stem from something because it has a very short lifespan. We have reason to believe that a surge of methane only lasts 300 years.
The TGO's advanced tools can provide methane measurements 3 times more accurate than previously recorded. It's also able to detect a distinct isotopic signature in methane molecules, a clue whether it's biological or geological in origin. Finding a biological origin for the methane on Mars would be an extraordinary discovery.
We have no idea whether this methane is coming from organic decomposition. Should this be the case, this will be definitely a sign.